Chapter 8 Earth's Mighty Mountains. The big question. How do the movements and forces of tectonic plates build mountains? The year was 1953. Mountain climbers Edmund Hillary and Tenzing Norgay stood on the hard-packed snow. They gasped for breath in the thin air. Their faces burned from the bitter cold wind. Despite this, they were grinning from ear to ear. Hillary and Norgay had just made it to the top of Mount Everest. They were the first people to reach Earth's highest point, 29,029 feet above sea level. Mountains are some of Earth's most awe-inspiring features. In 1953, geologists were still searching for answers as to how mountains form. By the 1960s, scientific evidence pointed to plate tectonics as a driving force behind mountain building. As you read in Chapter 2, our planet's rocky exterior isn't one solid piece. It is broken up into a collection of gigantic tectonic plates. Earth's tectonic plates move slowly, but their movements have dramatically changed Earth's features over time. Plate movements have shuffled Earth's continents into different positions. They have destroyed old oceans and created new ones. They have also built mountains and mountain ranges in several different ways. Colliding continents. Some of Earth's highest mountain ranges formed as sections of continental crust collided over millions of years. The collision that formed Mount Everest is a good example. Everest is part of the Himalayas, a vast, towering mountain range between India and China. The Himalayas formed when continents on two tectonic plates met head-on. Can you find India on the map? It lies along the southern edge of Asia. India wasn't always where it is today. Hundreds of millions of years ago, India was an island. It sat out in the middle of the Indo-Australian plate. It was separated from Asia, which sits on the Eurasian plate, by an ancient ocean called the Tethys Sea. The Indo-Australian plate began creeping northward about 200 million years ago. Driven by moving magma in the mantle below, it slowly collided with the Eurasian plate. Where the two plates met, subduction took place. The heavier oceanic crust of the Indo-Australian plate slid under the lighter continental crust of the Eurasian plate. As the Indo-Australian plate kept moving northward, India was carried along. It inched closer and closer to Asia. The Tethys Sea began to disappear. India finally collided with Asia around 40 million years ago. India's rocky continental crust pressed directly against Asia's continental crust. As the two landmasses continued to be pushed harder and harder together, the continental crust began to crumple. Enormous pressure created by the moving tectonic plate caused the rocky crust to heave upward. Great masses of rock gradually rose up into a series of enormous folds. The Himalayas were born. More and more rocks were uplifted as the Indo-Australian plate kept moving. The Himalayas rose higher and higher. In fact, they are still rising. They are growing taller at about the same rate that your fingernails grow. Geologists classify the Himalayas as fold mountains. The name refers to the way rocks are pushed up into huge folds by moving tectonic plates. The Alps, Europe's highest mountains, are fold mountains that formed much like the Himalayas. The Appalachians in North America and the Urals in Russia also formed through collisions of continental crust. Like many other fold mountains, the Himalayas contain quite a bit of sedimentary rock. Why? In the case of the Himalayas, it started with the Tethys Sea. For millions of years, erosion washed sediments from Asia and the ancient island of India into the Tethys Sea. Countless layers of sediments, along with remains of ocean animals, were deposited on the seafloor. Over time, pressure and heat helped turn these sediments into sedimentary rock. As plate movements slowly brought India and Asia together, Some of these seafloor sedimentary rocks were pushed up. Heat and pressure from the colliding plates transformed some of them into metamorphic rocks. Other sedimentary rocks remained relatively unchanged. This is how fossils of ancient ocean animals ended up on top of Mount Everest. Fossils at the top of the world. Trilobites and crinoids are two of the most common types of fossils on Mount Everest. Trilobites were hard-shelled ocean animals related to modern-day crabs and lobsters. Trilobites lived on the bottom of Earth's ancient oceans, including the Tethys Sea. Crinoids were animals too, but they looked more like plants. Trilobites and most crinoids became extinct about 250 million years ago. A few types of crinoids still survive far below the ocean's surface. Folding at the edges. Along South America's western coast, the oceanic Nazca Plate has been sliding under the South American plate for millions of years. This caused massive folds of rock to pile up along the edge of the continent. These folds are now the Andes Mountains, the longest mountain range on land. As you read in Chapter 4, the edge of a subducting plate melts as it descends into Earth's hot mantle. The resulting magma moves up through cracks in the crust. It may erupt on the surface to form volcanoes. The edge of the Nazca Plate is melting as it slides beneath the South American plate. Erupting magma has created many volcanoes in the Andes mountain range. Faults and blocks. The longest, highest mountain ranges on land are mostly fold mountains. However, moving tectonic plates build mountains in other ways. Fault block mountains form when gigantic blocks of rock move up and down along faults. At some faults, such as the San Andreas Fault in California, blocks of rock move horizontally past each other as they slip. At other faults, slips cause blocks of rock on one side of the fault to move up. These slips also cause blocks on the other side of the fault to move down. Repeated slips gradually force these rock blocks higher and lower to create fault block mountain ranges. Fault block mountains typically have one steep side and one sloping side. The steep side forms a high, sheer cliff. Germany's Harz Mountains are one example of fault block mountains. Others include the Grand Tetons in Wyoming and the Basin and Range province of Utah, Nevada, and Arizona. Under the dome. Most people think of sharp, jagged peaks when they hear the word mountains. Dome mountains are quite different. Dome mountains look like great humps of rock with rounded tops. They usually occur as isolated mountains on otherwise flat plains. Some dome mountains form when magma pushes upward into Earth's crust from the mantle. The magma cools into igneous rock before reaching the surface. This huge lump of igneous rock causes the crust above it to bulge, like a blister on skin. Utah's Navajo Mountain is a good example of a dome mountain that formed this way. Mountains on the Prairie. You can see the Black Hills of western South Dakota from a long way off. These dome mountains rise up from the surrounding grassy plains as dark, hunched shapes. They are the highest mountains east of the Rocky Mountains. Very ancient granite forms the core of the Black Hills. Millions of years of weathering and erosion have exposed this igneous rock in many places. The sculptor Gutzon Borglum made one tall granite formation in the Black Hills famous. He carved the faces of 4 presidents into the rock to create Mount Rushmore National Memorial. Another sculpture in the Black Hills has also gained attention as the world's largest sculpture in progress. Crazy Horse Memorial honors North American Indian heritage and depicts the face of the Sioux leader Crazy Horse. Started in 1948 by sculptor Korczak Zielkowski, work on the massive sculpture still continues today.